Besides completely randomized design, there are two other variations on experimental design, including blocked and matched pairs. So, why do we pursue these? The main reason we might is if we can't control all the factors that might affect the outcomes. There are certain things we cannot assign to subjects. We can't tell them their sex, their ethnicity, their age, the day of the week, if we're looking at production, batch, or size. All of those might have some differences compared to others that we want to control for. So, our solution is to run separate experiments based on the factors you can't control. So a blocked experiment basically looks like two regular experiments. You have your block 1 subjects, group 1, group 2, or more if you need, treatment 1 and treatment 2, and then you compare. Then you have your second block, group 3, group 4, they both get the treatments and you compare. So you basically have two or more experiments where you block them according to ethnicity or gender or age because of they're going to respond differently because of those factors. So let's go ahead and create a completely randomized block design for my investigation of grading, automated grading. So if I had pre-AP geometry, that would be one group that I would block for. And if I had regular geometry, I would block for them separately because there would be a lot of difference in these two scores based on the way the classes are. So I wouldn't want to have my pre-AP geometry mixed with my regular geometry. Now, sometimes the variability in the blocks is still too big and it masks the effects of a treatment. In this instance, you want to more closely match subjects or trials based on similar factors. So here you have your pairs. You're going to pair them up. Frequently, twins is a common type of pair, or you could have husband wives, depending on what's going on. All right. Match pairs is great when you have either matching pairs of experimental units, such as twins, and then you randomize the treatment in the block. Or you can apply two different treatments to each unit. This is actually very common. And it could be before and after, pre-test and post-test, or no randomization at all. Now, I actually did use a match pairs for my initial investigation. Why did I do that? Well, first of all, let's see how I use match pairs. Basically, I graded all my students using regular grading in the fall. And then I graded the same students using automated grading in the spring. So this was sort of a before and after, and I was comparing them to district scores to see if they improved. And they did, by the way. So why did I use matched pairs instead of one of the other designs? Because you could say, well, maybe something changed from spring to fall, actually, or fall to spring. And actually, it's harder in the spring. So if anything, the score should have gone down, not up. Why did I use match pairs? Well, it would be very hard for me to have two grading systems going on in the same course, and especially in the same classroom. It wouldn't be fair to the students for me to grade one student one way and one student the other way, especially if the grading actually provided an advantage to one of the groups. When I do version quizzes and tests, I try very much to keep them equal for the same reason. I want to make sure my students have fair assessments across the board. Now, do be careful. Make sure nothing else changes on a before or after. So if I had changed my curriculum or my note style or anything else that was a big factor, that would affect my results. Bad things can happen to good experiments, so record any data that may be relevant. It's always good to pre-test surveys and experiments.